Observability and monitoring are critical components of managing and securing Kubernetes clusters. They provide insights into the health, performance, and behavior of applications and infrastructure, enabling teams to detect issues, troubleshoot problems, and optimize performance. Following is a detailed overview of observability and monitoring in Kubernetes, including key concepts and best practices. Key pillars of observability in Kubernetes. Metrics. Quantitative data about the state and performance of the system, example, CPU usage, memory consumption, request rates. Collected from Kubernetes components, example, API server, kubelet, and applications running in pods. Logs. Text-based records of events and activities generated by applications, containers, and Kubernetes components. Essential for debugging and understanding application behavior. Traces. Records of the flow of requests through distributed systems, helping to identify bottlenecks and latency issues. Particularly useful in microservices architectures. Events. Kubernetes-specific records of changes in the cluster, example, pod creation, node failures. Provide context for troubleshooting and auditing. Kubernetes monitoring architecture. Kubernetes monitoring involves collecting data from multiple layers. Cluster-level monitoring. Monitor the health and performance of Kubernetes components, example, API server, etcd, kubelet. Track node-level metrics, example, CPU, memory, disk usage. Workload-level monitoring. Monitor pods, deployments, and services. Track application-specific metrics, example, request latency, error rates. Infrastructure-level monitoring. Monitor underlying infrastructure, example, VMs, storage, network. Key metrics to monitor in Kubernetes. Cluster-level metrics. Node CPU and memory usage. Pod scheduling and eviction rates. API server request latency and error rates. etcd storage size and latency. Workload-level metrics. Pod CPU and memory usage. Container restarts and crashes. Network traffic and latency. Application-specific metrics, example, HTTP request rates, error rates. Infrastructure-level metrics. Disk I/O and storage usage. Network bandwidth and packet loss. Host-level resource utilization. Best practices for observability and monitoring in Kubernetes. Enable cluster-wide monitoring. Use tools like Prometheus and Grafana to monitor all layers of the Kubernetes stack. Centralize logs. Aggregate logs from all pods and nodes into a centralized logging system, example, Elasticsearch Stack or Loki. Implement distributed tracing. Use tracing tools like Jaeger or OpenTelemetry to monitor request flows in microservices. Set up alerts. Define alerting rules in Prometheus or other monitoring tools to notify teams of critical issues, example, high CPU usage, pod crashes. Monitor application-specific metrics. Instrument applications to expose custom metrics, example, using Prometheus client libraries. Use Kubernetes native tools. Leverage tools like kubectl top, kubectl logs, and kubectl describe for real-time insights. Monitor resource quotas and limits. Track resource usage to ensure applications stay within defined quotas and limits. Regularly audit and optimize. Continuously review monitoring data to identify performance bottlenecks and optimize resource usage. Challenges in Kubernetes observability. Dynamic nature of Kubernetes. Pods and nodes are ephemeral, making it challenging to track long-term metrics and logs. Scale and complexity. Large clusters with hundreds of nodes and thousands of pods generate massive amounts of data. Multi-tenancy. Monitoring workloads in shared clusters requires careful isolation and access control. Tool integration. Combining multiple tools, example, Prometheus, Grafana, Jaeger, into a cohesive observability stack can be complex. By implementing a robust observability and monitoring strategy, teams can gain deep insights into their Kubernetes environments, ensuring reliability, performance, and security.